Now we're going to look at adding and subtracting matrices. It's pretty easy because we're just adding and subtracting corresponding elements. The first thing I kind of want to look at to demonstrate or to remind you is about the dimensions of these matrices. In number 9, this first matrix has 2 rows and 3 columns. So this is a 2 by 3 matrix. The second matrix has also 2 rows by 3 columns. In order to add or subtract matrices, the dimensions must be the same. Otherwise, all the elements will not correspond. For example, whenever we're adding these two together, we're going to add corresponding elements. The upper left added to the upper left. So 1 plus 3 is 4. Then the middle, negative 2 added to 9. Negative 2 plus 9 is 7. Then we have 0 plus negative 3, which is negative 3. Then we just finished the second row. 3 plus negative 9 is negative 6. Negative 5 plus 6 is a positive 1. And 7 plus 12 is 19. And that would be the answer to our first addition here for matrix number 9. Also notice that it too is a 2 by 3 matrix. All the dimensions are the same. In number 10, the first thing we have to do is scalar multiply the fractions 3/4 and 2/3. You should recognize that terminology, scalar multiplication or scalar multiply from your Algebra 1. What we're going to do is simply, the thought would be to distribute. So I'm going to multiply 3/4 times 8, 3/4 times 12, 3/4 times negative 16, and 3/4 times 20. I'm going to distribute that in. So we have 3/4 times 8. If you don't have a calculator, you would say 4 will go into 8 2 times. 2 times 3 is 6. 4 will go into 12 3 times. 3 times 3 is 9. 4 will go into negative 16, negative 4. Negative 4 times 3 is negative 12. And 4 will go into 25. 5 times 3 is 15. So I've scalar multiplied 3/4 into that first matrix. In the second matrix, I'm going to scalar multiply 2/3 to each of these terms. If you have a calculator, you can just calculate it. If you don't, old-fashioned way says 3 will go into 27 9 times. 9 times 2 is 18. 3 will go into negative 9, negative 3. Negative 3 times 2 is negative 6. 3 will go into 54 18 times. 18 times 2 is 36. And 3 will go into negative 18, negative 6. Negative 6 times 2 is negative 12. Once you have scalar multiplied, whatever that number is on the outside, then you just go through and you do the addition in corresponding elements. So I have 6 plus 18 is 24. 9 plus negative 6 is 3. 12 plus 36, negative 12 plus 36 is 24. And 15 plus negative 12 is a positive 3. Again, we can go back and kind of look again to see the dimensions. I start off with a 2 by 2 on both of these matrices, and my final answer is a 2 by 2. And this also is a square matrix because it's the same horizontal and vertical rows and columns. So I have to first scalar multiply and then do the operation addition or subtraction. These are a few terms that we need to remember. We have additive identity matrix, which really makes sense. What type of matrix would I add to keep the same identity? It would be a matrix of zeros. So in all the elements of this particular matrix, all the elements will be 0. Because then I can say 1 plus 0 and keep the 1. 2 plus 0 and keep 2. 5 plus 0 and 5 stays the same. And negative 7 plus 0 keeps its same identity of negative 7. So the additive identity matrix is just a matrix of zeros. Inverse matrix is just that. It's the inverse of whatever those elements are. And again, another word for inverse would be opposites. So if I'm looking at the opposites, so that I get, this is opposites, I want to I want my final matrix to be a 0 matrix. So when I add the positive 2 and the negative 2, I get the 0. The positive 8 and negative 8, again I get 0. Negative 3 and positive 3, 0. And so I end up with a 0 matrix. So when you add inverse matrices together, you get the 0 matrix because they're opposites. Number 11 is one we just kind of threw in here to show corresponding parts and corresponding elements within the matrices, and also it's going to kind of bring back that elimination process. In this particular one, number 11, we have this first row, and it's the first column, is a binomial. So the binomial 2x plus y, and I also have the binomial x minus y. But they correspond. X minus y corresponds to 5, and 2x plus y corresponds to 16. Now if they're equal, then the left side equals to the right side, so I can set those equal. I have 2x plus y equal to 16. So it creates an equation with two variables. Then in the second one, I have x minus y is equal to 5. Again, if you look at it carefully, you can see that we can use the elimination process and eliminate the y's. So the y's will eliminate with positive and negative. Add up the x's, that's 3x. Add up your constants, that equals to 21. Divide by the coefficient 3, and x equals 7. Then we just plug that back into either one and solve for y. So if x is 7, I'm going to put it right back in for x, and I have 2 times 7 plus y is equal to 16. So 14 plus y is equal to 16. Subtract 14, and y is 2. So the two answers that I come up with are x is 7 and y is 2. And I can plug those back in and check just to double check that the answers are correct. We have some subtraction. You have to be careful with subtraction. There's two ways to look at it. You can subtract or you can add the opposite. I'm just going to walk through again and just do the subtraction. I'm looking at this. I have 2 rows by 3 columns, and I have 2 rows by 3 columns, so everything corresponds. And I know my final answer will be a 2 by 3 matrix. So I go through and I just do the subtraction. I have 6 minus a negative 4. Minus the negative becomes plus a positive, so that is 10. Negative 9 minus 3 is negative 9 and negative 3, which is negative 12. Then 7 minus 0, of course that would just be 7. So that's my first row. Negative 2 minus 6, so that's a negative 2 and a negative 6, which is negative 8. 1 minus 5, and 1 minus 5 is negative 4. 8 minus 10. 8 and negative 10 give you a negative 2. And again, this answer is a 2 by 3 matrix. 2 rows by 3 columns. Number 13, we have that, again, a scalar multiple. And in that scalar multiple, we have to distribute the 7 and distribute the negative 2, or subtract, distribute the 2. Either one. So I'm going to begin with distributing the 7. So in this first matrix, I'm going to multiply 7 times each term in there. 2 times 7, 7 times negative 1, 7 times 8, which is 56. Then I have 7 times 4, 7 times 7, and 7 times 9. Then we have minus. Minus. Once you have that minus, then you just sort of have to ignore this minus right there. And just distribute the 2, because here's the minus right here. I can't use the minus and the negative at the same time. So now I distribute 2. 2 times negative 1, 2 times 4, 2 times negative 3, 2 times 7, 2 times 2, and 2 times negative 6. So then I have to remember that I am subtracting, and then I subtract and find my final answer with corresponding elements. 14 minus a negative 2, minus a negative is plus a positive, so this is 16. Let's see if I can write that better. Then negative 7 minus 8, negative 7 and negative 8 is negative 15. 56 minus a negative 6 minus a negative is plus a positive, so that's going to be 62. Second row, 28 minus 14 is going to be 14. And then 49 minus 4 is 45. 63 minus a negative 12 minus a negative is plus a positive, and that would be 75. So unless I made some careless errors, which I hope I haven't, this is a 2 by 3 to begin with, minus a 2 by 3, and again I end up with 2 rows by 3 columns for my answer.